All right, welcome. In the world of AI, there's this constant struggle to get things, well, just right. Not too simple and definitely not too complex. It's what we call the Goldilocks problem of machine learning, and honestly, getting it wrong can make a super powerful AI model pretty much useless. So let's dive into this. I want you to think about it like this for a second. When you study for a big exam, are you really learning the concepts? Understanding the why behind it all? Or are you just memorizing the answers to the practice questions? Because that is the exact same challenge that AI models face every single day. And that right there brings us to the absolute core of what we're trying to do. The real goal, kind of the holy grail of machine learning, is this one word, generalization. It just means how well can a model perform on new stuff it's never seen before. It's not about the practice test, it's all about acing that final exam. So let's break down the first way this can all go wrong. This is what happens when our AI, our student, just doesn't hit the books hard enough. We have a name for this. It's called underfitting. Underfitting is, well, exactly what it sounds like. The model is just too basic. Imagine trying to describe a really complex, curvy road with just a single straight line. It's never going to work, right? The model just doesn't have the complexity it needs to grasp the real patterns hiding in the data, so it ends up learning almost nothing at all. And this chart shows you exactly what happens. Just look at the performance here. The training error, that's our practice test. It's high. And the test error, our final exam, is also high. Our student failed both. Why? Because they never really learned the material to begin with. Makes sense, right?
Okay, now let's swing to the complete opposite end of the spectrum. This is our student who didn't just study. Oh no, they memorized every single comma and period in the textbook, but they didn't understand a single concept. This is the too complex problem, overfitting. So here's the key thing to get. An overfit model learns the training data too well. It doesn't just learn the important stuff, the signal. It actually memorizes all the random, useless details, what we call the noise. It becomes so specialized on its practice questions that it completely falls apart when it sees something new.
Now, what's so wild about this is just how tricky overfitting can be. Take a look at that training error. It's practically zero. On paper, the model looks like an absolute genius on the practice test. But then, look at the test error. It's through the roof. It totally bombs the final exam because, as we know, just memorizing things isn't the same as truly learning.
Okay, so we've got these two big traps, right? Too simple and too complex. So how in the world do data scientists find that perfect, just right balance? Let's take a look at the toolkit they use to figure this stuff out and, more importantly, how to fix it. This table just lays it all out so perfectly. You can see the clear differences in complexity and error that we've been talking about. But now look at those last two rows, bias and variance. These are super important. Think of high bias in underfitting as a student who has a really strong but totally wrong idea. Like they think every answer is C. The model is biased towards a simple, wrong pattern. On the other hand, high variance in overfitting is like a student who's hypersensitive to every tiny detail in the practice questions. Their answers are all over the place when you give them a new question. This whole bias-variance trade-off is the fundamental balancing act that data scientists are constantly trying to manage.
And how do they actually check for this stuff? Well, they basically create our school analogy in real life. From the very beginning, they split their data. They use one big chunk for training, that's the practice test, but they keep a separate, untouched part for testing, that's the final exam. By comparing how the model does on both, they can see if it actually learned or if it just memorized. Pretty clever.
So what if your model is too simple? Well, the fixes are pretty intuitive. If you want it to learn more, you can literally increase its complexity. Give it a bigger brain. You can also feed it better, more useful information to work with. You could even reduce some of the rules that might be holding it back. Or, hey, maybe just give it more time to study the data. Fixing a model that's too complex, though, that requires a totally different mindset. You have to force it to generalize. That might mean reining in its complexity, maybe by adding penalties for getting too complicated. You could give it a wider variety of examples to learn from, so it can't just memorize one type of problem. And one of the most popular tricks? Simply stop the training process early. It's like pulling the student out of the library before they start memorizing all the random useless trivia.
Now, I know this all might sound a little bit abstract, like a bunch of theory, but I promise you, getting this balance right is one of the most critical parts of building AI that actually works in the real world. This is where the rubber really meets the road.
This quote here from the source material just says it all. You can build a model that looks absolutely perfect in the lab, scoring 99.9% accuracy. But if it's overfit, the very moment you release it into the wild, it can fail and fail spectacularly.
And let's be clear, the stakes could not be higher. We're talking about fields where an overfit model, one that maybe saw a weird shadow once in its training data, might cause a self-driving car to swerve for no reason. Or an underfit model that's just too simple to spot the subtle signs of a financial crash or a dangerous medical condition. This isn't just some academic problem. This can have life-or-death consequences. So, as we keep building these ever more powerful and mind-bogglingly complex AI systems, it leaves us with a really fascinating question to think about. Maybe, just maybe, the biggest challenge ahead isn't just teaching AI what it should learn, but getting much, much better at teaching it what it needs to ignore.